November 1942. A Polish resistance fighter stands in a stairwell of a Warsaw apartment building, holding a weapon assembled from 9 stamped metal parts and 4 springs. The gun weighs 3.2 kilograms, measures 762 millimeters in length with the stock extended, and fires 9mm parabellum ammunition at approximately 550 rounds per minute from a 32-round side-mounted magazine. It cost the British government about 10 shillings to manufacture, less than half the price of a standard pair of military boots. The weapon has no finish, no wooden furniture, no aesthetic considerations of any kind. The welds are visible and crude. The barrel is a length of hydraulic tubing. The stock, a simple metal frame. The magazine housing protrudes horizontally from the left side, creating an unbalanced profile. The resistance fighter hears German voices ascending the stairs. He aims at the landing, pulls the trigger, and nothing happens. The safety catch, a rotating collar around the magazine housing, has engaged accidentally. He rotates it, aims again, and fires a 3-round burst. The gun functions. 2 German soldiers fall. The weapon that fired those rounds was the Sten gun, and between 1941 and 1945, over 4 million were manufactured, making it one of the most widely produced submachine guns of the war, and decades later, one of the most commonly encountered weapons in European organized crime. The British military in 1941 faced an infantry armament crisis that was industrial and strategic. The evacuation from Dunkirk had cost the British Expeditionary Force most of its equipment, including approximately 68,000 firearms. Remaining stocks of Thompson submachine guns were expensive, required extensive machining, and could not be produced quickly enough to meet rearmament demands. The Thompson cost approximately £50 per unit and required 40 hours of skilled machining labor. Britain needed a submachine gun that could be mass-produced using minimal machining, that could be manufactured in facilities without specialized gunsmithing equipment, that required unskilled or semi-skilled labor, and that cost virtually nothing to make. The weapon needed to be reliable enough for combat, but did not need to be durable for long service life. It needed to kill efficiently at close range, but did not need accuracy beyond 100 meters. These specifications demanded abandoning every convention of quality firearms manufacture. Development began in late 1940 at the Royal Small Arms Factory Enfield under the direction of Major Reginald Shepherd and Harold Turpin, whose initials would form the acronym STEN. The design philosophy was radical. Eliminate every component that required machining beyond basic stamping, welding, and drilling. The receiver was formed from a stamped steel tube. The barrel was cold-drawn hydraulic tubing, requiring no internal machining beyond basic rifling. The bolt was a cylindrical steel mass with a fixed firing pin. The magazine housing was welded to the receiver. The trigger mechanism used stamped parts. The stock, a bent steel rod. The total parts count was 47 components, compared to over 200 for a Thompson. Manufacturing required approximately 5 hours of labor, most of it unskilled. Cost per unit was approximately 10 shillings, 1/100th the cost of a Thompson. The weapon operated on a simple blowback principle, identical to most submachine guns. When fired, the bolt was driven rearward by recoil, compressing a return spring. As the bolt traveled backwards, it extracted and ejected the spent casing. The spring then drove the bolt forward, stripping a fresh round from the magazine and chambering it. The fixed firing pin struck the primer as the bolt closed, firing the next round. This cycle repeated at approximately 550 rounds per minute as long as the trigger was held and ammunition remained. Muzzle velocity was approximately 365 meters per second. The effective range was optimistically listed as 100 meters, but the practical combat range was under 50 meters due to the weapon's rudimentary sights and inherent inaccuracy. The critical design flaw, recognized immediately but accepted as unavoidable, was the side-mounted magazine. Mounting the magazine horizontally from the left side simplified manufacturing by allowing the magazine housing to be welded directly to a flat surface of the receiver tube. This created severe balance problems. The weapon was awkward to carry, prone to snagging on equipment, and the magazine was vulnerable to damage or dislodge. Worse, the horizontal magazine allowed debris to enter the feed mechanism more easily than vertical mounting. Mud, sand, or even minor impacts could cause feeding malfunctions. The safety mechanism, a rotating collar around the magazine housing, could rotate accidentally during movement, rendering the weapon inoperable at critical moments. These flaws were documented extensively during trials and accepted because the alternative was having no submachine guns at all. Production began in June 1941, with initial batches designated the Sten Mark I. This version retained some machined components and a wooden foregrip. The Mark II, introduced in 1942, eliminated all unnecessary machining and became the standard variant. Over 2 million Mark II Stens were produced. The weapon was manufactured in factories across Britain, Canada, and New Zealand. Production was deliberately designed to prevent a single-point failure from bombing. Small workshops, bicycle factories, and automotive plants were retooled to produce Sten components. The weapon's simplicity meant production could be distributed widely without requiring specialized facilities. Operational deployment began in 1942 with issues to the British and Commonwealth forces across all theaters. Combat reports were mixed. The weapon functioned adequately when clean and properly maintained, but was notoriously unreliable under adverse conditions. Soldiers complained about accidental discharges caused by the weapon firing when dropped or struck. The side-mounted magazine was universally disliked. Accuracy was poor enough that the weapon was considered useless beyond close range. Despite these limitations, the weapon was valued for its lightweight, compact size and the simple fact that it provided automatic firepower to troops who otherwise would carry only bolt-action rifles. The weapon's defining role became equipping resistance movements in occupied Europe. The Sten's simple construction made it ideal for clandestine manufacturing in improvised workshops. Resistance groups in Poland, France, Denmark, and elsewhere produced unlicensed copies using locally available materials. The British SOE airdropped thousands of Stens to resistance networks, often in kit form, requiring assembly. The weapon's low cost meant it was expendable. If captured or damaged, it could be discarded without significant loss. This disposability made it psychologically easier for resistance fighters to engage in operations where weapon recovery was impossible. The Sten became the weapon of choice for assassinations, ambushes, and sabotage operations, where rapid fire at close range was essential and long-term weapon retention was unlikely. Comparison with German and Soviet submachine guns reveals the Sten's distinctive characteristics. The German MP40 was more refined, more reliable, and more expensive. It cost approximately 60 Reichsmarks to produce, 6 times the Sten's cost, and required skilled labor. The Soviet PPSH-41 was cheaper than the MP40, but still required more manufacturing time than the Sten. The American M3 grease gun, introduced in 1943, used similar stamped metal construction principles, but cost approximately $20, twice the Sten's cost. The Sten remained the cheapest mass-producible submachine gun of the war, though this came at the cost of reliability and user confidence. The limitations became apparent in sustained combat use. The weapon's tendency to fire when dropped led to numerous friendly fire incidents. The magazine's side mounting caused chronic feeding problems that were never satisfactorily resolved. Soldiers learned to carry the weapon carefully, to avoid loading the magazine to full capacity, to reduce spring tension, and to expect occasional malfunctions. Training emphasized immediate action drills for clearing stoppages. Units operating in dusty or muddy conditions reported malfunction rates approaching 30%, unacceptable by normal standards, but tolerated because the weapon could be replaced easily. Post-war surplus distribution created Sten's second career as a criminal weapon. Hundreds of thousands remained in storage depots across Europe. Many were stolen or sold on black markets. The weapon's simple construction made it easy to maintain and repair without specialized knowledge. Its compact size allowed concealment. The availability of 9mm ammunition, a common European pistol caliber, meant ammunition could be sourced easily. By the 1960s, the Sten had become ubiquitous in European organized crime. Bank robberies, assassinations, and gang conflicts across Italy, France, and Britain frequently involved Stens. Police reports from this period document Sten recoveries in criminal contexts far exceeding recoveries of other military weapons. The gun designed for emergency wartime production became the weapon of choice for criminals who valued availability and disposability over reliability or sophistication. The criminal use led to legislative responses. Multiple European nations implemented firearms laws specifically targeting submachine guns in response to Sten-related violence. Remaining military stocks were destroyed systematically in the 1970s and 1980s to reduce criminal availability. Despite these efforts, Stens continued appearing in criminal contexts into the 1990s. The weapon's simple design also made it easy to copy. Improvised Sten variants, manufactured in illegal workshops, appeared in conflicts and criminal enterprises worldwide. The legacy of emergency wartime production was a weapon so simple that it could be replicated by anyone with basic metalworking skills. Production statistics are well documented. Over 4 million Stens were manufactured in all variants during the war. Approximately 100,000 remain in military or museum collections. The remainder were destroyed, lost, stolen, or exist in unknown locations. The weapon that cost less than a pair of boots to manufacture killed efficiently in circumstances where more expensive weapons would have been unavailable. Its reliability was poor, its accuracy was marginal, its ergonomics were terrible. None of this mattered when the alternative was no weapon at all. The Sten succeeded by being adequate when adequacy was sufficient, and by being so cheap that millions could be produced when millions were needed. The resistance fighter in Warsaw, who experienced a safety malfunction before successfully engaging German soldiers, was one of thousands who learned that the Sten worked precisely well enough, precisely often enough, to be worth carrying despite its flaws.